All right, guys, welcome back to class. Today we're going to be moving on to chapter 9. All right, this is going to be about preparing for attacks and exploitation of our process. This is when things are starting to get a little bit of fun. Because up to now, we've done a lot of reconnaissance and we've done a lot of scanning. But now we're going to shift our gears a little bit and we're going to prepare for the actual exploitation phase. Now, the roadmap for today. First, we're going to start about planning. We're going to discuss how to prioritize our targets and map out the attack paths for each. We're going to cover how to evaluate each exploit, specifically looking at where do we find them and how do we vet them. We're going to then talk about payloads. We need to understand the difference between bind and reverse shells, which is a critical concept of bypassing firewalls. And then finally, we'll talk a little bit about Metasploit. Okay, we'll dive into the Metasploit framework, its tools, including MSF Console and MSM Venom. All right, so the shift here is going to be as we transition from being an analyst, where we were just used to looking at data, to being an attacker. Now we have a map from all of our recon. Now we need to choose our route. We can't just attack everything randomly. We need to plan out everything with prioritization and then also possible pivot points. Now the timeline here we've got to think about as well. Notice that the business plan timeline on the slide has real engagements, have schedules. We need to make sure that our attack itself also is going to fit into the allotted time. Because remember, if we go back to our rules of engagement, there's a lot of do's and don'ts. And remember, what's going to change from being a criminal versus an actual consultant is that rules of engagement and making sure that we stay within our guidelines. Now we need to prioritize our target itself. So when we start looking at the list of potential targets, we need to evaluate them based on a few different criterias. The first thing I want to look at is exploitability. Is it low-hanging fruit? Are we looking at targets that are easy to exploit with maybe some high reliability, like Eternal Blue or even default credentials? What's the impact? What is the value of this? High-value targets like domain controllers or PII databases, these are our crown jewels. So what's the impact if we do get into these servers? Then we need to position ourselves. How does the target offer a bridge? Does it have dual home, like the servers act as pivot points to get us into the network from maybe the DMZ to the internal network? How is it positioned within a network, and how could it help an attacker gain additional foothold within a network? So we're going to pick the path of least resistance. Let's be honest, attackers are going to be lazy. So we're going to prioritize the targets that are practically guaranteed to work. If you see a vulnerability with a CVSS score of 9.0, like remote execution, and no authentication is required, well, that's probably going to be our first stop. Good examples of this would be like Tomcat with admin credentials or unpatched WebLogic servers as we go through them. Now these high value target, as we like to call them, is the crown jewels. These are the systems that justify the entire budget of a pen test. Compromising a domain controller or a payment processor proves maximum business impact. If we can get into these, we win the game. It's not just about popping a shell, it's about what the shell gives us access to. Now we need to think about pivot points. Does this attack server that we're going after have a strategic location? Because sometimes the machine isn't valuable for the data it holds, but where it sits. Maybe it's a bridge, like a printer in the CEO's office that might be boring on its own, but if it's on the same network as the internal database, it might be golden. What attackers are doing here is we're looking for lateral movement. This is going to allow us to pivot deeper into a network, moving from a low security zone into maybe something a high security zone. This is why we look at printers and IoT devices so strongly when we're doing penetration testing. Now we're going to identify different attack paths. We need to visualize the chain of events from outside to inside. For example, what's that chain look like? Do we fish our way in or use a web exploit? And once we're on either the workstation or the server, how do we gain a foothold? Can we get local admin privileges onto that machine? Can we pivot laterally through the network? And then finally, can we reach our objective, like maybe a domain controller from the outside? Now, we need to do some research on our exploits before we can do anything, because we need to find in examples. Just a minute, turning on some focus mode. We need to find some examples that are actually able to get into the server. We need to find what we like to call the right weapon. Now, you're often going to look at the code like HTML or the script itself for examples that are shown. You need to be comfortable reading headers and scripts and understand what the exploit is and what it actually is targeting. So where do we actually find these exploits? Well, there's a few different places that we can look, but one of my favorite places is going to be ExploitDB. Now, this is a standard archive curated by Offensive Security, the same people that do like the OSCP certification. And you need to be able to use things like SearchSploit to search it offline. And this is actually something that is a lot of times built into Metasploit as well, just so you know. We could easily pull this if we have internet access. Now, we could also move into GitHub. GitHub is going to be a little bit more with the latest proof of concepts. They're going to be they're going to be the most up to date, but be warned, this code normally is unverified and sometimes can be risky itself. It could be a virus in itself. Okay, so we have to be careful there. And then lastly, we have PacketStorm, which is a long-standing archive. It's very great for finding historical exploits and security advisories. So I like to use PacketStorm if I'm looking for something really old. Now, with that said, ExploitDB does a pretty good job of it as well. ExploitDB also goes a step further and gives you those payloads automatically. Okay. Now, we want to evaluate the reliability. Now, the reliability of each one of these exploits. Because the first question is, will it work? Not all exploits are created equal. We're going to need to vet them. Now, we can check if ExploitDB marks this as verified. That's one way for verification. But the other thing we need to do is make sure that we match the exact version in OS. For instance, we may be talking about Apache 2.4.49, or is it 2.4.50? This is a difference, and we need to make sure that they do match what we're looking for. Because sometimes we also need to look at the stability. Logic flaws are usually safer than memory corruption exploits. Because if we deal with a memory corruption exploit, like a buffer overflow, we could crash the service or even the server entirely. So we have to be very careful here. That's why we do need to make sure we evaluate the side effects. Many exploits, especially those who rely on memory corruption, will crash the service if they fail. So the production rules here is never run an unstable exploit on a production server without explicit permission. You don't want to be the one who takes down the company's email server at 10 o'clock in the morning. Now, the cardinal rule here is something that I can't stress enough. Never run a script from the internet blindly. You might want to read it. Now, it might contain things like a backdoor or commands like rm-rf. So you have to be careful that you might not become the attacker. And so we need to read the scripts and understand how they work before we use them. Let's move on to understanding payloads. understanding payloads, we need to understand the execution, okay? The exploit is just an entry method. This is how we get in the door. How do we bust open the door? The payload is a code that runs after the door is kicked open. Now we got two different types that we need to know about. We've got bind versus reverse shells and stage versus stageless payloads. In the screenshot here, we can see MSF Venom generating a Linux bind shell. Note that the payload side is only 105 bytes, and we're dealing with buffer overflows here. Now, what is a payload itself? Well, if the exploit is the missile, the payload is the warhead. It defines what happens once we're successful. Maybe it's open a command shell, or add a user, or execute a command. Maybe it's to install a remote access Trojan like Meterpreter. Now, as seen in the example, we can output payloads in various formats like ELF for Linux executables. So the bind shell itself, this is where the attacker connects directly to the victim on a listening port. The payload's going to open a port like 4444 on the target. Now, the problem here is firewalls almost always are going to block us from incoming connection. This rarely is going to work over the internet, but might work in a local network, in an internal network. So what you find over the internet a lot of times is what we like to call a reverse shell. Now, the reverse shell is, well, how does the victim attack back to the attacker? Firewalls usually allow traffic outside the network, so this is a standard method for penetration testing. If you want to look at the diagram here, you can see that the victim initiates the connection out to the attacker, while any incoming connection is probably blocked by the firewall. The next payload type is going to be staged versus stageless. Staged is small and flexible. It's saying we're going to send a very tiny stager first, which is going to download the full payload. This is perfect for things like buffer overflows where memory space is tight. Okay. Now, stageless, this is reliable, but unfortunately, they can be quite large. It then sends the entire payload at once, and a more stable, they're a lot more stable, but we can only use if the space permits. A lot of times there's not enough space for us to run our entire payload in memory, so we might not be able to use stageless. Now, the Swiss Army knife is a tool. The Metasploit framework is a Swiss Army knife tool that I like to mention quite a bit. We've mentioned it a few times, did it in our labs for this class. But know that Metasploit is the industry standard tool for exploitation. What's cool about it is it's going to integrate things like scanning, like the Nmap scanner that you see in the picture to the right. It's also going to have things like exploitation and payload generation all in one application. So what is Metasploit? It's an open source platform for developing, testing, and executing exploit code. It's very standardized. We have to select the exploit, we need to select the payload, configure it, and then we launch it. Pretty much everything in Metasploit is set up the same way. As you can see in the banner, it contains thousands of exploits and payloads. It all depends on what version you download, but when you open it up, you get a different ASCII art every time, and it has a ton of different payloads and exploits that we can use. It's updated almost daily. Now, you need to know the four main types of modules within Metasploit. The first type is going to be the exploit. This is where the code targets the vulnerability. Once we have the exploit, we need to know what payload are we going to send after kicking in that door. And so the payload is the code that runs after the success. We have some other things too in the auxiliary, such as scanners, fuzzers, and sniffers. These also will help us identify which exploit or payloads we are allowed to use. And then we have post, which is tools for looting and maintaining access after compromise. This is where we can also gain persistence. Now, once you first launch into it, you're going to have the MSF console. This is our cockpit. Now, there are some basic commands that you probably should know in Metasploit. So these are ones that I would memorize for the Pentest Plus. The first one would be search. Search allows you to find modules. So maybe I'm dealing with VSFTP. Maybe I'll search for VSFTP. Once I know what module I want to use, I can use it by saying use and insert the module name here. Once I have selected a module, you'll see it in red on the interpreter screen. We want to then show options. Show options, or just type in the word options and hit enter. This will let you know what needs to be configured for this exploit to run. You're going to set those options like remote host, local host. And then when we're ready to go, we'll run it or we'll type exploit. One of the two will work. This will launch the attack. Now, if it works, hey, maybe we get in and complete what we were trying to do. If it doesn't work, it will error out and let us know. Now, there are some key options on the target. So when we said we're going to set some of those things, our host and our port is definitely one of those options we want to do. So this is going to be target features. Our host stands for remote hosts, and that's where we put the IP address of the victim we're trying to attack. Our port would be the remote port, and this is where we put the port of the vulnerable service that's listening, like 445 for SMB or 443 for HTTPS, whatever we are trying to attack. Now, once we have those settings set, we can go back to the callback. It's no good if we exploit into a system and it doesn't call back to us. So we may do an lhost. Lhost stands for localhost. This is our IP address. This is where the reverse shell will connect back to. Lport is this local port. It's the port that you are listening on. This is what our server is listening on. By default, it's 4444. Now, there's going to be a couple different payloads. We talked a little bit about that. And sometimes we're going to need a payload outside of Metasploit. MSF Venom generates payloads like .exe, .elf, .apk if we need different types of payloads. Now, the command is here, kind of harder to read, but it'll be like MSF Venom -p for what payload, -lhost for the IP, -lport for the port, and then -f for format, and then what is the output that we want to put this to. It's really cool because we can now specialize the payload depending on the devices that we're trying to penetrate. Now, we do need to have a listener because if we throw a ball, you need to catch it. So MSF Venom is going to create a reversed shell. We need something to catch that connection, and this is our lhost and lport. Now, the module here would maybe say exploit multi-handler. These are things that we like to use quite often, and this is going to help us catch incoming connections. So that gets you all the way through Metasploit. Now, when you do the lab for these chapters, pay attention to these commands. These commands will become second nature as you use them more and more. Now, as a recap, we learned how to prioritize targets based on low resistance and high value. We know that there's now databases like ExploitDB, and even though we pull the code that's been verified, we should read the code and ensure reliability and safety. We don't want to just run somebody's code right on our server, especially production. We learned payloads, and we learned that we prefer reverse shells to help us bypass firewalls. And then we learned the basics of Metasploit. So as we go through this, you'll be able to play with these tools, get used to them a little bit more. Metasploit is one of the tools that I would definitely make sure that you know of before you go sit down for the Pentest Plus. So we're ready to go to the next chapter, which is going to be network attacks. And we're going to use some of the tools that we learned in this chapter in order to complete those. I'll see you for chapter 10.